Okay, so the test that's coming up next is graphing. Now, how come we're having a test so soon? Because you've already learned a lot of this stuff before, and it's just the graphing portion of what you've learned. You haven't been tested on that yet. So what have you learned? Well, some of it's as simple as just graph this. Instead of like find the domain of it, just graph it. Would you just sketch that for me quick? Obviously, it begs the question, do you know what the square root of x looks like? Because if you don't know what that parent function looks like, you won't know how to do it. So, all right. So I'm going to pull up out of my gallery. I'll pull up a nice graph there. All right, the parent points on this are this, over 4 and up 2 and over 9 and up 3. If you don't know those parent points for all of the major graphs, then you're going to have major trouble on this test. Okay, so if I were you, I'd make sure you knew what the parent points are for each of them. I am going to sketch all of them for you right now. You might want to do the same on your paper to remind yourself. All right, here's the first one, square root function. Here's the next one. Take a guess what I'm doing now. Absolute value function. Okay, there's the absolute value function in red. Here is the parabola function. I'll do that in empty circles so that you can see where those spots are going. Over 2 and up 4, over 2 and up 4, over 3 and up 9, over 3 and up 9. Okay, so there's the parabola. What else do you have to know? 1 over x, yep. And 1 over x has this spot right here, which I'll put an x on top of now. And it also has all of those points. Remember how it gets closer and closer and never touches? And it also goes through that. And all of those points. So the green one is the 1 over x function. X cubed, you have to know the John Travolta function. Okay, so that one goes like this. I'll put big red dots for this. Now I've just blocked out a whole bunch, but that's okay. They all go through 0, 0, and they all go through, not all, but close. Go through 1, 1. And then over 2 and up 8. And then you can't see it unless I scroll down here, so down 8, 2, 3, 4, 5, 6, 7, 8. Okay, those are the main ones you need to know. I don't think we're going to do anything yet with sine or cosine. You'll eventually have to know those, but I don't think for this test you're going to have to worry about that. Okay, any questions about the parent ones? All right then. I'm going to go back to my original question. I'm going to undo everything I just did there and get it back to just that blue one. Okay. Now it has to go where? With that minus, what's that minus 2? Right 2. So I take every dot and move it to the right 2. 1, 2 spots over. 1, 2 spots over. This is going to go off my screen, but there it would be. Okay. Think of each equation, or each function as a whole bunch of points put together. They're all separate little points. It's a collection of points. And each of these points just needs to move wherever it tells you to. In this case, it's 2 to the right. All right, what if it was much more complicated? What if it was like this? Y equals negative 3, absolute value of 2, parentheses, x minus 4. What order would you do that in? And would it matter? Oh, yes, it would. You have to know the order that these go in. All right, so I want you to write this one down. And I want you to make a list for me. 1, 2, 3, 4. What do you think should be first, second, third, and fourth thing that you do? You know it's a V shape, right? It's absolute value. So what would you do? Well, there's 4 things. Don't say it, please. Just write it. Do you think we should go to the right 4 first? Then go ahead and write that down. Unfortunately, you'd be wrong. But you can write it down. if you don't really have a clue, then pay good attention to this part, because the order is the only thing that's really hard about this. Otherwise, you did it all last year. It's just moves and flips and you know, it's not that hard. But the order matters. All right. I have tried to teach you that you always start on the inside on hard problems. Okay, so you start on the inside. If there's nested parentheses, you have the parentheses that are in the parentheses, you know, go in as far as you can. Start on the inside. And once you're in there, do you get that when you're on the inside that you can't trust what's going on in there? It always is the opposite of what you think. Therefore, this would normally be first because it's in parentheses. And parentheses are normally first. Therefore, it can't be first. You get what I'm saying? It's in the opposite of normal order. So therefore, that 2 has to be first. All right, so if that 2 is first, what is that 2 doing? It's a left-right thing. Is it making it wider or narrower? Narrower, because you'd think it was making it twice as wide, but this is counterintuitive in here, so it's half as wide. Or you could say a horizontal shrink. The next step is, you're still on the inside, right? So this has got to go to the other thing, which is that, which is right 4. Now I can move to the outside. And in this case, all I have a choice between is the stretch or the flip. The 3 times taller or the flip. So you tell me, in gymnastics as well as in math, was it smart to stretch first before you flip? Yes, it is. Stretch before you flip. You might pull a muscle. All right, so stretch first. So it's 3 times taller. And then the last thing is, which kind of a flip is that? Up, down, or left, right? Up, down. Stuff on the outside is up, down stuff. Now the official name for up, down flip is a reflection. And you could say it was up and down and therefore not horizontal, but vertical. You could say it's a vertical reflection, or you could say it's a reflection over the which axis? It's going this way, it's going over the x-axis. Yep. So this would be a reflect over x. But I like saying up-down flip just because it makes sense to me. Up-down stuff, left-right stuff. Okay. Did you get that this is the right order, and that if you do things in math in the wrong order, it goofs things up? It does. The order of operations is crucial. Now, of course, there's times when the order of operations doesn't really matter. In this case, does the order of operations matter? Will you get a different answer if you multiply first and then add? So if I did this first and did 5 times 6, then that'd be 30. Or what if I did this first? 3 times 6 is 18 times 2. Is that 30? No, you get 2 different answers. So yeah, it matters what order you do things in. So you got to be careful. Now sometimes if you change this around to, let's say it's all multiplied. Now it doesn't matter what order you do it in, because it's all tied. What if it's tied like multiply and divide? A lot of people think if it's multiply and divide, then you always multiply first. False. Multiply and divide are tied in value. If you're picking between them, then which one do you have to do? It does matter. Left to right. When it's a tie, it goes to whichever one's on the left. Okay? So this would be first 2/3 and then times 6. So 2/3 times 6 would be 12 over 18 is your final answer, but that can reduce to 6 was in there twice. 2/3. Oh, it doesn't make sense. 12. Okay, what did I just do wrong? 2/3. 2 divided by 3 is 2/3, yes. Times 6, so that should be 12. Oh, it's not 12/18ths. It's 12/3. Okay, there we go. Just 4. Whew. And if I do it in the other order, it'd be 6 times 3 is 18. And 2 divided by 18 is 1/9. 1/9 is obviously way different than 4. So yes, the order matters. Okay, one more. Tell me, there's 3 things going on here. What should you do first? No, 4 things. Second, third, and fourth. and make sure it's in the right order. All right, first, start on the inside. Well, there's several things on the inside. Normally, parentheses go first, and so they don't. Those two things are what you pick from next. What do you normally do first? Stretch before you flip, or flip before you stretch? Stretch before you flip. This is what you normally do first, and so therefore, you don't stretch. You flip first. That's a left-right flip. Also known as a reflection, horizontally, or a reflection over the y-axis. The second thing then is the stretch, and that would be 2 times taller. No, not even 2 times taller or anything. It's not 2 times wider. It's half as wide. And then third thing is that +1 there. What's that mean? Left 1. And then the last thing I would do is that 3 in front, which is what? 3 times taller, otherwise known as a vertical stretch of 3, or a lot of ways to say it. Did anybody have that in the perfect right order? Okay, see how tough that is? We only got 5 people that had it right. Okay. All right, one more time. I think you can all get it this time. Four things again. What's first? What's second? What's third? What's fourth? This is not only going to help you on today's test, it's going to help you on the next test after this one. Because they do a lot of these asking, okay, what's first, second, third, and fourth? Because that's a communications test, I believe. It's like communicating about the function. All right, Miss W. Tell me how to start. Okay. Generally, how do you start? How about this? Inside or outside? Generally start on the inside, which is this stuff. Now, I'll ask you this question by question. I bet you can answer it right. What normally goes first, parentheses or other things? And therefore, they don't go first. And therefore, I'm going to do that first. And so you should therefore do the 1/2. Now, is that half as wide or is that twice as wide? Twice as wide. 2 times wider. Who had that right? Raise your hand if you did. Awesome. Okay, next step. I go in and do that 5. That's easy. Right 5. That's it. That's all there is to that. Next part, go to the outside. On the outside, do you do it in normal order? Yes, you do. So those are the two things. What's normally first, times by 2 or +7? Times by 2. So therefore, it's 2 times taller. And the last thing you do is the +7, which will be up 7. There they are in the right order. Yes? Good question. I would be okay with what I just wrote on the board. It'd be fine. All right. Now, let's have you actually look at a graph for a second again. I know you don't have graph paper, but imagine for a moment that you had to do this one. 2 times, and then let's throw a negative in front of that. 2 times the square root of negative, parentheses, x minus 2, parentheses. Sketch it. Remember, the order matters. Doing the wrong order? That's why we were doing all that. Doing the wrong order, you're likely to get the wrong answer. So I hope you start on the inside. And more specifically, parentheses are normally first, and so therefore we don't do that first. We should do this first. So you have a square root that looks like this. And now you should flip it left, right. First. You get when I flipped it, it basically looks like that. Okay. Now what should I do to it? What's that minus 2? Come on. What's the minus 2 mean? Right 2. Okay, so I go right 2. Okay. And now what's that times by 2 in the front going to do? Twice as tall. So I'm going to go, instead of over 1 up 1, I got to go over 1 up 2. See what I'm doing here? It's going to go from here to here. It's getting twice as tall. And instead of ending out at 3, it's going to end out at 6. See that the upper blue one is twice as tall as the lower blue one is? All right. So there's my final answer. Now, this thing I'm about to tell you here is a really killer application for this test that you're going to take. It's going to help you so much. Listen, if you want to be sure you're right, test some points on an XY chart. You can be positive on every problem on this test that you did it right. All you have to do is test some points. So let me show you what I mean. Do you get that if I could somehow make this, by putting any number I want right there, do you get how I could somehow make that come out to be a nice square root? Okay, so give me a number that would actually make it work out nice. Positive 2. All right. If I put in positive 2 right there, I'm saying that the point 2 comma something must be on my graph. All right? So then, if I put in a 2, what's 2 minus 2? 0. What's the opposite of 0? It's just 0. What's the square root of 0? What's 2 times 0? So 2 comma 0 better be on my graph. Look, 2 comma 0. It's on my graph. It's right there. See? It worked. Okay, what's another point that would work out nice? 1. All right, I'm going to back up, put in a 1 in there. Put a 1 right there. If I put in a 1 there, it'll be 1 minus 2, which makes negative 1. And then I have a negative in front of that, which makes it positive 1. And that's the square root of 1, which is 1. And I times it by 2, and that makes 2. So if I put in a 1, I get a 2. Look, I put in a 1, I get a 2. That's that point right there. See? It's working. You see how you can be sure you were right? If your graph was going like this somehow, you'd be like, oh, wait a minute. It's not in the right spot. You'd be able to check yourself before you wreck yourself. Okay. All right. So, just check points. It really, really, really works. You can do it on the most complicated functions. You can always go back to your XY chart. I'm going to try one more. Do you get that this point right here should be in there? So what can I do? I can look back and say, okay, that's x is 0, and y better come out to 3. If I stick in x is 0, let's see if it comes out to 3. If I stick in a 0 here, I got negative 2, and then I got a negative in front of that, makes it 2. Square root of 2, uh-oh. Well, why is that not working out so well? Because I just was sketching this graph. Okay, I didn't make it perfect on that spot. Let's finish this. This would be 2 times the square root of 2. Do you get that 2 times the square root of the 2 would be pretty close to 3? Okay, so I was just kind of guessing when I drew it. That point may go a little lower than that. It might be more like this. You know what I'm saying? So don't freak out if it's not exactly perfect, but it's really close. Now, you won't have a calculator on this test. Why? Because it's a graphing test. And you can just type every one of them into your calculator in graphic. Okay, so obviously there'll be no graphing calculators on this test. All right. So please, please remember that you can check points because it will really, really help you. I don't want to grade lots of bad papers. Frankly, it's way easier for me to grade your paper if you have an A. It goes a lot faster. Okay, so how about we I'll work towards that. All right, next thought. Piecewise. They're Frankenfunctions. Let's do it this way. Business in the front, party in the back. It's the mullet function. Do you get how that's two functions put together? So I'd say for the green one that it was y equals absolute value of x for a while. For what period of time was it that? It was that from negative infinity until I hit what? 0. And now it's all about these endpoints. That's where these piecewise, that's what's going to get you on this test, is the endpoints. All right, do you get how it looks right now like both of my functions are at 0? It can't be. It's got to be one or the other. So here's what you do. You actually have the same function except with an empty spot on the end of it. And now I'm going to group these together. Group. Okay. Okay, and now I'm going to put this back in. Do you get now that I just made an empty spot there for the black function? And therefore the green one is the one that actually owns that 0 point. So I'm going to put a bracket around that. And the black function here has an empty spot at 0. So that one is y equals the square root of x function. And it works from 0 to infinity. And does it work at 0? No, so I put parentheses here. All right, so most kids can get the basics of these really easily, but then the endpoints are the things that mess them up. Let's see if I can get you on this one. Do you get that that's just a parabola that's been shifted up too? All right, so then I'd like you to graph this where it's the absolute value function from negative infinity up until it hits 0, including 0. And it starts again at 0, but it can't be 0 because it's already 0 up on this one, to infinity. Graph that. Remember, it's the endpoints that are crucial. All right. If I was just simply graphing both of them, I'd go like this. There's the absolute value function. Here's this parabola that's been shifted up to. But you know what? That wouldn't be a function. Do you get how it wouldn't pass the vertical line test? So it's only one of these functions for the first part. So the first part is this, and then it works for that function at 0. Then it starts over on the other function and goes up. Empty spot there, goes up like that. Raise your hand if you had that one right. Awesome. All right, so that's all I'm going to say about these. What's the important part again? Endpoints. Endpoints. Check your endpoints, because that's where you're going to get these wrong. Yes? We will give you this part on the test. You will have to graph it from that. It's a lot of, almost every problem has a piece of graph paper on it, and you're just graphing something. Yes? All right, let's say I just have that. F of x equals 2. Is that saying that y equals 2 or that x equals 2? It's saying that y equals 2. How do I graph that? Y equals 2. Tell me one spot where y is 2. Yeah, about right there. And then you have to ask yourself, where's another spot where y is 2? Is it this going to go up or down, and this is going to go left, right? It's going to be left, right, so it's going to be like that. Okay, so that will be that function right there. That's all there is to it. Now, what if it's limited to between x? It only is that function between x is greater than 2 and less than 3. Well, then it's only that function between 2 and 3. So then it's only that function between like here and here. So then it's only that function right in there. And it must be some other function the other way. You know, like maybe from there it makes a parabola that goes up. Maybe at the beginning of it was an absolute value that was flipped upside down. Okay, so that'd be like a 3-part function. So if it's just f of x equals 2, yeah, that's just to saying y equals 2. It's just a line that goes straight across it. All right, so that's piecewise. And then the last thing I need to talk to you about is sawtooth functions. Reminds me of shark's teeth. I'll make one shorter on each end. Okay, so what if that's your function? What if they say f of x equals that? That is f of x. Then what they'd ask you is, what would 2f of x plus 1 look like? Well, remember how I said each function is a collection of points? Do you get how it's made up of this point, 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 and this point? Just connect the dots. Now tell me, what should I do to each of those points? What does that times 2 in the front do? Twice as tall. How tall is these 2 points right now? Yeah, so that's 0 high, so how far up should it go? Well, it goes twice whatever 0 is. Its height right now is 0, so it goes 2 times 0. And then what's that plus 1 at the end do? Moves it up 1. Move it up 1. At this point, it already was 1 high. Now I'm going to times it by 2 and then add 1. What's timesing it by 2 going to do? Make it 2, and then I got to add 1. Okay? This one was already 2 high. I'm going to times it by 2 and then add 1. This point's height is not going to change at all. Ooh, I forgot to take this guy and move him. I got to move him. His 2 times 0 is 0, but I'm going to add 1. This one, I go 2 times its height of 0, and then add 1. This one, it was height of 2, now it's going to go to height of 4, and then add 1. And this one's going to go, both of these are going to go up. They're going to 2 times 0 is 0, but add 1. 2 times 0 is 0, but add 1. This one's height was 1, and then 2 times that is 2, and then add 1. Oh, it's 2, there's 2, and then add 1. There, and then I connect it up. See, my new sawtooth function is twice as tall as the old one was. And you get that it's been moved up 1. That's what you should do when you're done, is make sure your shape makes sense to you. I can see that it should be twice as tall, and it should be up 1 from where it was. And now I can look at my shape and say, yeah, my sawtooth mountains there are twice as tall as they were, and they've all been moved up 1. Okay, so that's called a sawtooth function. That covers the stuff that mainly that you need to know for the test. I mean, cover absolutely everything, but that's most of it. And then we are going to review again tomorrow for the test. Your homework for tonight is only this. I know that you didn't have my help, other than the video, to do that assignment before on piecewise. Okay, make sure the assignment on piecewise and the other assignment on moving functions around look good. Check them. You have a whole extra night. There should be no excuse tomorrow when we grade them that you should have any trouble, in that you've had a whole extra day to work on it. Plus, there's answers that are going to get posted tonight. Okay, so take the time to do that. If there's any you didn't do before, do them now. You don't have anything new. And if you just take the night off, that's kind of tragic, considering there's a big test coming on Thursday. So take tonight to fix those old worksheets. All right, that's all I got for you for today.